Water. Simple water. It's all around us. We never spend any time thinking about how fascinating it actually is. So let me tell you my opinion about this. Hello, my name is Greg Friedman. I'm a bioengineer focused on studying electric discharges, and I often work with water. Let me tell you a story to start with. Long time ago, this was my first year master's, and I was putting together a setup. And to test it, I needed about a couple of milliliters of, the instructions said, clean water, do not use tap water. Well, all I had was tap water, so I go to lab next door, just kind of wander around like, hey, do you guys have any clean water? And I didn't know it at the time, but apparently the lab next door was doing some experiments for NASA where they required ultra high purity water. And the guy looks at me and is just like, how much do you need? And I'm like, I don't know, a cup. He's like, whoa, I can't spare that much. And I'm thinking to myself, like, what? Like, the way he said it is like, oh my God, like, you're asking for something huge. I'm like, yeah, just I really need like a couple of milliliters for the experiment. And he's like, all right. Did you bring a container? I'm like, I don't know, like, can I use this paper cup? And he looks at me like I'm just an idiot. And later I find out ultra pure water that they were working with, it's like 10 nines, like 99.999999999% pure. And it's about $1,000 a liter, or $1,000 for a quarter gallon of water. Yeah. Anyway, water it's an everyday liquid that has very surprising and unusual behavior. So let's talk about it. The water molecule, it's rather small. It's one oxygen, two hydrogens. It's bent. It's very polar. Oxygen is highly electronegative. It likes electrons very much. And the hydrogen doesn't really care that much. So hydrogen's electrons are mostly hanging out around the oxygen. So you have this kind of negative center and two positive centers. So water molecules, because of that, they're polar. And they kind of align nearby to each other, where hydrogens are facing oxygen, and even they form so-called hydrogen bonds, where even though hydrogen is married to this oxygen, it's a bit of an open relationship because it allows its electron to jump over to the other oxygen every so often. So this hydrogen bonding and electronegativity is what gives water its very interesting properties. Like imagine, you put a little bit of salt in that water, and all of the hydrogen bonds are disturbed in interesting ways because now oxygen can realign from the other hydrogen bond to the salt molecule. So I went to a conference once where I heard a lot of lectures on water clusterization inside of the fluid and water forming these clusters of 47 water molecules around one ion. There's lots of very fascinating science. Like, have you thought about what happens to water when it gets cold? When the water freezes, the hydrogen bonding is looser, so ice is actually bigger volume than liquid water. So water expands as it freezes. It's pretty cool. Another result of this, even though water is a very small molecule, it has a rather high boiling point for what it is, allowing life to exist in the way that it does. It has high heat capacity, high heat of vaporization, and all of that is due to this hydrogen bonding. For the same reason, because of this hydrogen bonding, the surface tension of water is very high, especially of ultra-pure water. So as you add impurities, you make the water less and less adherent to each other, or coherent, and you decrease surface tension. Interestingly, plasma is a surface phenomena, so when you're plasma treating liquid, you're reducing surface tension, but only at the surface. There's some cool things you can do because of that. As I mentioned in previous video, this hydrogen bonding, water balances cohesion and adhesion when it's at the surface, and that's why we use it for surface contact angle measurement. And water is just an exceptional solvent. It's a polar molecule, so anything polar or ionic will dissolve in water, or just like in the biology, like your cells are made out of lipids, and lipid is polar on one end and not polar on the other end, so it forms lipids, fats in the water. They form what are called these micelles, this little spherical balls, and very similar to mammalian cells. So life probably originated in water, and it probably originated in water because of water's fascinating properties. And that's why, water, you read these super novel publications in Nature and Science magazines, and very often a study on water pops up. The more I read about water, the more I'm fascinated about it. And the last story I will tell you is quite curious for me. I do this demo to undergrads, and they usually love it. Cup of water. Go to your sink, fill up a cup of water. Is it solid or liquid? Well, turns out the answer depends on time scale. So because, this is like really cool. So this hydrogen bonding, how does it actually work? So it's oxygen, two hydrogens, and kind of sitting next to oxygen and two hydrogens, and the water forms sheets. So what you think is liquid kind of isn't. Imagine a stack of paper, big stack of printer paper. It's solid, it's paper, right? Now throw it in the air and watch it. If you take high-speed photographs, each photograph shows you hundreds, thousands of sheets of paper, right? But if you're just looking at it and the wind is blowing and all the sheets of paper are just floating in the air, looks like liquid, doesn't it? Same as your cup of water. On a picosecond time scale, all it is bunch of sheets of paper kind of next to each other. And then 100 picoseconds later, the water molecules shift and the sheets of paper change form. But on a very fast time scale, water is actually solid. And we use this pretty fascinating phenomenon in plasma. Typically when you read about plasma, every book starts with plasma is a gas phase phenomena. Well, did you know you can create plasma in liquid with no gas at all? You need a very, very fast power supply. You need power supply that can give you sub-nanosecond voltage rise. And then what happens? Electrons, they like running on surfaces. They attach to the surface and just jump on it. So electrons use this sheet-like property of water to create plasma between the sheets of water. It's kind of cool. Anyway, I find water fascinating. Let me know what you think about this subject, and let me know if you have any questions or comments. I'm happy to do deeper dives on these topics, or whatever interests you. If I can answer it, I'll try. Peace. See you in the next one.